This is Jason Lau and Jack Fluth on black holes and why you should be worried. So, to start off, we wanted to learn about black holes because there's not much known about them right now. In fact, there is very little studies done on black holes, and there's more on why they are not real. But they are, and we need to be worried about them. The main topics that we are focusing on are what even is a black hole, because most people are unaware today. We also want to know how they work and what they do to our universe, and the dangers that the black holes possess, as well as what we can do to stop them from destroying our life. So we really were interested in this topic because this is a very big deal, and almost no one knows anything about it. So now let me turn it over to Jason on what even a black hole is.
So, in order to understand what a black hole is, we need to know how it forms. It all starts at the stellar nebula. The stellar nebula will either turn into an average star or a massive star. The massive star will undergo nuclear fusion in order to balance a gravitational pull to balance the gravitational pull. The nuclear fusion will achieve this through creating massive amounts of energy, which prevents the star from collapsing on itself. When the star runs out of energy, it will lose its ability to resist the gravitational pull and collapse on itself, creating a supernova. If the star initially has a large enough mass after collapsing, it will form into a black hole. But if the mass isn't large enough, it will be a neutron star. And what a black hole is essentially it's a highly concentrated ball of mass that has a very strong gravitational pull towards it, so that many things cannot escape its pull.
So building on that, you want to think of it as something like, imagine if the Earth were to be transformed into the size of a peanut. All of the mass would still be retained, except for it would be a much smaller size, so it would be extremely dense. So this is kind of like, you're kind of glimpsing now what a black hole is. It's super small, super dense, and super big mass. So the mass is as shown in the equation. V is equal to square root of 2gm over r. The mass is super large, and the radius of the object, black hole, is super small. So that will result in a super large velocity. Now this velocity is greater than the speed of light, which explains why why light cannot be seen coming out of it or anything else. Because to our knowledge, there is nothing that can go faster than the speed of light, or if there is, we can't detect it. And what a black hole is like when you suck something in, you can't suck something larger than yourself into yourself. So it's kind of like a black hole. If it was the size of a mouse, it would not be able to suck in a house because it's much bigger than it. So it'll just gradually start to eat away at the larger object, and eventually, when it will take the rest of it with it, gaining in size. So during this entire time, it just keeps gaining mass and gaining until it is super massive. And there's a theory right now that at the center of the universe, at the center, there is all of these galaxies rotating, rotating around this massive black hole. And now we will go on to Jason with the dangers of a black hole.
As we stated earlier, a black hole has a very strong gravitational pull. And in order to overcome that gravitational pull and escape it, you're going to have a really quick, fast velocity, as Jack stated. And this velocity will have to be greater than the speed of light. And the only thing that we've ever been able to even see to travel that fast is in the movies like Star Wars and Star Trek, where they're going warp speed through the galaxy, and like you can't even see anything if they're that fast. And so our technology nowadays, it cannot go that fast. It can't go like half that speed. So we need to create faster and better technology that can escape a black hole. Other ways to escape it is what, Jack?
Other ways to escape it also would be very nice to have, because with our technology today, going faster than the speed of light is not foreseen to happen within tens of, maybe even hundreds of thousands of years. So if there is a better way to deal with this, we would like to have that as soon as possible, which can only be done through more research.
Um, and the next thing that can makes a black hole dangerous is that they can literally form at any time, just like bam, we're dead, because we won't have enough time to react. And that's why we need to start studying them now, so that whenever they do happen, we can be prepared to like have an escape route or like a defensive plan against them. And as we all stated earlier, and it's the most important one, is that we have no way to escape at this current moment. And so that is why that brings us to our next point.
So what can we even do about these? These things seem so insurmountable and impossible to do anything against that why do we even care? Well, this is similar to things like global warming in the past. No one really knew anything about it or even cared. Someone said to you, "What's global warming?" Well, who cares? It doesn't affect me. I don't know anything about it. But over time, it became known that it was a very big issue and it was destroying our world. And this is black holes. They can just like that. We're done. There's nothing left. And we need everyone to fully understand the risks and everything that's going to come with it. With public awareness leads to more people caring about the topic. More people, not enough people today, are studying about black holes and the dangers that it causes to us. So public awareness will hopefully, create more people who will be willing to research on this topic. It will also start to bring in more monetary funds in order to fund the research for black holes. This is extremely important. In things like global warming research, no one really would have known that it was destroying our world if people didn't donate to the cause and help us to understand that we were killing our own world. And with black holes, we don't know. That might be happening right now. So we need to start research immediately. It should have been done years ago, but it hasn't, so we need to start now. Well, to conclude, we should recall what we went over. There was, what is a black hole and how is it formed? We learned that it started as a star, and over time, because of the lack of nuclear fission, it collapsed on itself and it formed a black hole. Now, how does it work? We know that the insanely small radius and insanely high mass leads to a super high escape velocity necessary to leave. Think of it like this. If you had a little pebble and a rocket ship, then the pebble they would both need to have the same velocity, even though they have a much different mass. Now, the rocket ship might take more energy to launch because it is a heavier object, and the pebble might need less, but in the end, the same amount of velocity is necessary. We also learned the dangers that a black hole imposes and how bad this can be for us. And we now know that we need to spread awareness and start now. So what you need to do is go out and tell people today what this is and the dangers it imposes. Thank you.